Section 13.6, Solving Radical Equations. The objective, solve equations that contain one or more radical expressions. The method for solving equations with radicals. Step 1. Isolate one of the radicals on one side of the equation. An equation may have more than one radical. Step 2. Raise both sides of the equation to the power corresponding to the index of the radical. Step 3. If the equation still contains a radical, repeat steps 1 and 2. Step 4. Solve the equation after all the radicals have been eliminated. Step 5. Please be sure to check all possible solutions in the original equation and eliminate any extraneous solutions. Example 1. Solve the equation, the square root of x squared plus 13 equals 7. Luckily, step 1 is already done. The radical's by itself on one side of the equation, so we're simply going to square both sides. The square root of x squared plus 13 squared equals 7 squared. On the left, I end up with x squared plus 13 equals 49 on the right. Notice the new equation has no radical. When I subtract 49 from both sides, I have x squared minus 36 equals 0. Now I'm going to factor that. That's a difference of squares, so it factors into x plus 6 times x minus 6 equals 0. X plus 6 gives me x equals negative 6 for a solution, and x minus 6 gives me x equals 6 for a solution. So we're trying x equals negative 6 or x equals 6. We're going to check both answers in our original equation. So I have the square root of negative 6 squared plus 13. Does that equal 7? And the square root of 6 squared plus 13. Does that equal 7? On the left, I now have the square root of 36 plus 13. Does that equal 7? And on the right, I have the square root of 36 plus 13. Does that equal 7? On the left, I have the square root of 49. Does that equal 7? On the right, the square root of 49. Does that equal 7? The square root of 49 is 7. So on both of those, I have 7 equals 7, which means both negative 6 and 6 are solutions. Example 2. Solve the equation, the square root of y squared minus 10y minus 11 equals 1 plus y. Once again, we have the radical by itself on the left-hand side of the equation, so I'm simply going to square both sides. The square root of y squared minus 10y minus 11 squared equals the quantity 1 plus y squared. That leaves me with y squared minus 10y minus 11 equals 1 plus 2y plus y squared. Moving everything to the left, I end up with negative 12y minus 12 equals 0. Now I'm going to move my 12 back over to the right. Negative 12y equals 12. Divide both sides by negative 12. Y equals negative 1. I'm going to check my solution. Square root of negative 1 squared minus 10 times negative 1 minus 11. Is that equal to 1 plus a negative 1? Now I have the square root of 1 plus 10 minus 11. Does that equal 0? 0 square root. Does that equal 0? 0 does equal 0. There's one solution, and that solution is negative 1. Example 3. Solve the equation. The square root of 3x plus 13 plus 3 equals 2x. I do not have my radical isolated, so I'm going to have to do that, and I'll do that by subtracting 3 from both sides. That's going to end up giving me the square root of 3x plus 13 equals 2x minus 3. Now I can square both sides. So I have the square root of 3x plus 13 squared equals the quantity 2x minus 3 squared. That gives me 3x plus 13 equals 4x squared minus 12x plus 9. Moving everything to the right, I have 0 equals 4x squared minus 15x minus 4. That factors into 0 equals 4x plus 1 times x minus 4. 4x plus 1 equals 0 yields x equals negative 1/4. X minus 4 equals 0 yields x equals 4. I'm going to check both answers in my original equation. So I have the square root of 3 times negative 1/4 plus 13 plus 3. Does that equal 2 times negative 1/4? And then does the square root of 3 times 4 plus 13 plus 3 equal 2 times 4? Simplifying on the left, I have the square root of 49 over 4 plus 3. Does that equal negative 1/2? And on the right, I have the square root of 25 plus 3. Does that equal 8? 7/2 plus 3/2, does that equal negative 1/2 on the left? 5 plus 3, does that equal 8 on the right? On the left, 7/2 plus 3 is 13/2, which is not equal to negative 1/2. But on the right, I do have 8 equals 8. Negative 1/4 is not a solution. However, the solution 4 is. Example 4, solve the equation. Square root of x plus 1 equals negative 3. We can actually stop right here. Remember, we've already said you can't take an even root of a number and have it be negative. That means we have a non-real solution. So we can't have a square root, a fourth root, a sixth root, an eighth root. We can't have an even root equal to a negative number. If you don't see it right there, you can go through the problem solving process. So I have the radical term isolated on the left. I can square both sides, so I have the square root of x plus 1 squared equals the quantity negative 3 squared. That gives me x plus 1 equals 9. I subtract 1 from both sides and I have x equals 8. Now I'm going to check that solution. So I have the square root of 8 plus 1. Does that equal negative 3? Does the square root of 9 equal negative 3? Square root of 9 is 3, which is not equal to negative 3. So 8 does not check, therefore there is no solution. It is possible that after checking the answers, you may find that none of the answers are solutions, which is what just happened to us. In this case, the answer is no solution. Example 5, solve the equation. Square root of x plus 4 equals square root of 3x minus 2. Since I have radicals on both sides of the equation, I can simply square both sides, which will eliminate my radicals. The square root of x plus 4 squared equals the square root of 3x minus 2 squared, which is x plus 4 equals 3x minus 2, which gives me 6 equals 2x. Dividing both sides by 2, I get x equals 3. Now I'm going to check 3 in my original problem and see if it's a true solution. So I have the square root of 3 plus 4. Does that equal the square root of 3 times 3 minus 2? That's the square root of 7 equals 7. Square root of 7 equals square root of 7, which is true. So there is a solution, and that solution is 3. Example 6. Solve the following equation containing a cube root. We have the cube root of 2x plus 1 equals 3. I'm going to have to isolate that cube root, so I'm going to have to subtract 1 from both sides. The cube root of 2x plus 1 equals 3. Subtracting 1 from both sides gives me cube root of 2x plus 1 equals 2. Now I'm going to cube both sides. The cube root of 2x plus 1 cubed equals 2 cubed, which gives me 2x plus 1 equals 8. When I solve that equation, I get x equals 7/2. So I subtracted 1 from both sides and divided by 2. Checking that solution in my original equation, I have the cube root of 2 times 7 halves plus 1 plus 1. Does that equal 3? That's the cube root of 7 plus 1 plus 1. Does that equal 3? Which is the cube root of 8 plus 1. Is that equal to 3? 2 plus 1, is that equal to 3? And yes, 3 is equal to 3. So I have one solution, and that solution is 7 halves.